Okay, we're recording. So before we start, I want to make sure everybody is on page 73. Okay, now question number 1, who wants to go? Okay, wow, we have everybody. That's good. Ethan Roberts, go ahead. Can you read the question first?
The total length of 2 ropes is 36. In one rope is 4 in longer than the other. What is the length of the longer rope?
Okay, Ethan, did you draw a model? So I am going to draw a model. I'm going to use this long, very thin and very long bar to represent the ropes. We know there are 2 of them, but one is 4 inches longer. So this part, I'm going to say that is the 4-inch, okay? So one is 4 inches longer than the other. And we know altogether, they measure 36 inches, okay? Now, what is the length of the longer rope? So the question is asking about this one, okay? So we're gonna say this one is the longer one. This is the shorter one. Now, Ethan Roberts, what did you do? What do you think?
I did it by adding like minus 34 minus 36
Very
equals
good. So 36 minus 4, that's 32 inches. And what does this 32 inches represent? Which part is this 32 inches in this picture?
the 32 inches represents the longer number of row.
This 32 inches represent the 2 shaded parts, right? Because you use 36, you subtracted 4 from 36. So what's left are these 2 parts. Is that right, Ethan Roberts? Are these 2 guys, right? And these 2 guys are of the same size, right? So now to get to the shorter rope, to get to the shorter one, what do we do? Ethan Roberts? So to get to the shorter one, we do 32 divided by 2. Is that right? So that's 16 inches. Now, but the question was asking, what is the length of the longer rope? We have to add the 4 inches back. So 20 inches. And we can check our answers. Check our answers here. 20 minus 16, that's 4 inches. So the longer rope is 4 inches longer than the shorter one, right? So that checks out. And now 20 plus 16, that's 36 inches. That means the total length of these 2 ropes is 36 inches. And that piece of information is checked out as well. So we're pretty confident that the longer rope is 20 inches long and the shorter is 16 inches long, although the question is not asking about the shorter one. So anybody have any questions before we move on? No questions? Now we're moving to the second problem. Who wants to do the second problem? Kevin, can you read the problem to us, please?
Nellie dreamed of 2 numbers. Her numbers add up to 20. When she subtracts one number from the other, she gets 8. What are the 2 numbers?
Wow, okay. Kevin, you know what? I'm gonna draw exactly the same picture as I did for the first problem. So I'm gonna use 2 bars. So this first bar is the bigger number, okay? And then the second bar is going to be the smaller number. And the question told us the 2 numbers add up to 20, okay? So everything together is 20. But then when she subtracts one number from the other one, she gets 8. So this part is 8. Now, what are these 2 numbers? Kevin, what did you do?
So first, I used what like 20 minus 8 equals 12.
Equals 12. Very good. So what does 12 represent in this picture I just drew here? What does 12?
I'm not really sure because in here there's a lot of hard things that I don't
Oh,
understand.
you cannot describe, but 12
Yeah.
basically, look at this shaded parts, these two parts. Okay, so I shaded out these two parts and they're of equal size. And 12 is basically these two bars together. That part is 12, right?
Okay.
Kevin, okay, then what do we do? What's the
And
second
then,
step here?
and then, so there are 2 units equal 12.
So each one of them,
yeah, each one of them equal 12. That's 2 units.
so 12 divided by 2?
Equals 6. So 1
6
unit is 6.
is 6, okay? Now what are these two numbers? So the bigger number is 6 plus 8, right?
Equals 14. One is 14 and the other is 6.
Very good. And the smaller number is just 6. Okay, so I'm going to frame these numbers, 14 and 6. And we're moving on to the third problem, guys. Let me maximize the screen. Okay, do we have anyone who wants to work on the third problem with me? Andrew, go ahead.
Oh, and I also want to tell you, my dad made me do this 2 weeks ago.
Oh, okay. Yeah, Andrew, why don't you read the question first?
All right. Mindy has 32 pencils. Karen has 18 pencils. How many pencils must Mindy give to Karen so that each of them will have the same number of pencils? B. How many pencils will each person have then?
Okay, so what do we do here? Can I draw a picture first? I'm gonna draw Mindy. I'm going to use this longer bar to represent Mindy because Mindy, we know that she has more pencils. So Mindy has this long bar and Karen has a shorter bar. Karen has something like this, okay? So this part, this whole thing is 32 and this whole thing is 18. Now the question is asking how many pencils must Mindy give to Karen so that they have the same number of pencils. So we know that there's 14 more, 32 minus 18. So this part is 14. And we need to give Karen a part of that 14 pencils so that Mindy is gonna have the same. So after this part goes to here, now they should have the same. Okay, so what do we do here? Andrew, what do we do here? Andrew? So we're basically moving, look at me here. Okay, so this part is shaded. We're moving this part to Karen. We're giving this part of the pencils to Karen. And then they're all the same. So if you really look closely, this part here, the question mark here, is actually the same size as this part as well, right? Because after the giving, they're all the same. Both of them are the same. So, and we also know this part here is 32 minus 18 is 14 pencils. So what do we do here, Andrew?
So if that part 14 pencils, then if half of it's 7.
Very good. So you need to give half of this 14 pencils to Karen. So the half of it is 7 pencils, right? So now we figured out question number A. Now what about B? How many pencils will each person have then? So after Mindy gave 7 pencils to Karen, how many pencils would they have, each person? So Mindy gave 7. So 32 minus 7, that's 25, right? That's what Mindy has. This is what Mindy has. Now, Karen has 18, but she received 7 from Karen. Oh, I'm sorry. Karen had 18, but she received 7 from Mindy. So Karen now has 25 pencils.
Oh, I
So
thought.
both of them have the same number of pencils, right?
I kind of thought I got it wrong because I kind of used the same equation.
Oh, okay. Yeah. So this one is a little tricky, but I want to remind you that this question, if you have any trouble understanding the third problem, you can always go to example 1, right? The first example for your challenging problem. There is the very similar example in the front of the challenging problems. So you can always go back. And we're not going to talk about problem number 4 is because, let me write it here. So number 4 is just the same as 1 or 2. So if you have any problem with this, question number 4, you can always go back to number 1 or number 2 to kind of get an idea. Okay, we're moving on to 5. Anybody did 5? Ethan, go ahead.
A slow printer prints 5 pages per minute. A fast printer prints 12 pages per minute. How many more pages does the fast printer print than the slow printer in 10 minutes?
Okay, so what did you do, Ethan?
So first, I calculated how much the slow printer prints, how many pages the slow printer prints in 10 minutes.
Okay.
So since there's
5 per
10,
minute.
so since there's 5 pages and 10 minutes, I did 10 times 5
Very
equals
good.
50. So it prints 50 for 10 minutes. And then I did the
Okay.
same for the fast printer, and it can do 120 pages. So to see how much more the fast printer can do, I just subtracted 50 from 120, and the answer is 70.
Very good. Thank you so much. This is one of the methods. I want to show you guys another method. So let's call this method number 1. Method number 1. And I also want to do a method number 2 here. So method number 2 is really to figure out for every minute. So we're going to do for every minute, how many more pages does the fast printer print than the slow printer? So for every minute, you've got, not 8, sorry, 12 minus 5. Every minute, there's 7 more pages printed from the fast printer compared to the slow printer. So now we have 10 minutes. 7 times 10 equals 70 pages. Very good. So I want to remind you, right? This chapter is called what? 4 operations, right? 4 operations. So in a word problem, you take multiple steps. Sometimes you're using addition, subtraction for the first step, and then you do the multiplication division for the second step. So for the first method, we did multiplication first, then we did subtraction. For the second method, we did subtraction first, and then we do the multiplication second, right? But you should get to 70 pages, no matter what you do, right? So that's the answer, 70 pages. Going to the next problem, guys. Who wants to do the next one? Okay, we have Kevin, we have Yunyi. Yunyi, go ahead.
Lucy saves $2 a week to buy a comic book. She has saved $4. The comic book costs $16. How many more weeks? How many more weeks must she save before he can buy the book?
Okay, what do you think, Ringyi? So should I draw a picture again? So she has, okay, so let me just do this. A comic book, so the total amount she need is 16. We know that. So this is a book cost $16. But she already has
$4.
$4. So she saved $4. And then she needs to save more, but every week she only save $2 per week. Now the question is asking how many more weeks? So how many? So if this is a 4 and if this is a 2, then how many of these twos? That's the question. How many of these twos should she have here in the bar before she can buy this $16 book? Okay, so Yingyi, what do we do here?
16 minus 4.
Okay, that's $12.
Yeah.
So that's how much she should save more before she can buy it, right?
Mm-hmm.
Okay, and then what did you do?
I did 12 divided by 2, so it only takes her 6 weeks to.
Okay, 6 more weeks. 6 more weeks. Very good. Thank you so much. 12 divided by 2 because each week she saves 2 more dollars. Okay. And she needs to save $12. So I saw Abigail. Abigail, I saw you raising your hand for the last problem. You want to work with me on problem 7? Yeah, go ahead, Abigail. Can you read the problem to us?
Yeah. A train has 5 cars, each 7 meters long. The cars are joined by
Connectors.
connectors in length 3 meters. How long is the train?
Okay, how long is the train? So, okay, hold on, Abigail. I'm going to actually extend this picture because we only have 3 cars here. I'm going to just draw one more car at the back, and I'm also going to draw one more car in the front. So now we have 5 cars, and each of these cars is 7 meters. So I'm going to draw that as well. So, okay, Abigail, we are all set. Tell us what you did.
So I first the 7 times 5 equals 35, and
Hold on.
then
So, Abigail, what does this 35 represent? What does this number mean? What is this 35?
the total length
The total length for what?
of cars.
Very good. The total length of the 5 cars. And then what did you do?
And then I did 3 times 4, and
Very
it
good.
equaled 12.
Then what does this 12 meters mean?
Total length of the connector.
Very good. So the total length of the 4 connectors. And I also want to remind you guys, remember we talked about something like intervals, right? And we said the number of intervals equals the number of trees minus 1. Here you can think of that as well. The number of connectors here, that's like your interval, okay? So number of connectors here equals the number of cars minus 1. We have 5 cars, so we should have 4 intervals, okay? And now what's the last step here, Abigail?
And
we
then
need
I
one
did
more. Yeah.
35 plus 12 equals 47.
Very good. Beautiful. Thank you so much. Now 40, add up the length of the cars and the length of the connectors. We have 47 meters for the total length of the train. Okay. Now moving on to the next question. Who wants to do this one? Flora, you have been really quiet. Can you work with me on this one?
Damon ordered 4 books from an overseas bookstore. Each book cost the same, and there was a $5 postage charge for the order. His total bill was $33. How much did one book cost?
Okay, hold on a sec, Flora. I'm going to draw a picture here. So what I'm going to do is that I'm going to do 4 boxes, okay? So we don't know the price, but the 4 boxes are basically representing the 4 books that he bought. And then we're gonna add up some, this box here is the postage. We know that's $5 postage, and this whole thing is total bill. His total bill, we know that this total bill is $33. Now, what do we do here? What do we do here, Flora?
I use 33 minus 5 equals 28.
Okay. And so what does that 28 mean? $28, right? $28. What does $28 mean?
$28 means how much the books cost.
So $28 is basically the total cost of the 4 books, right? And we know that the 4 books, they cost the same, which means they all have the same price, right? Then what do we do?
Then I use 28 divided 4.
Divided by
Equals-
4, then you get
equals
$7. Now that's each one, right? So we can say this is the single price for the books, or we can say this is how much one book costs, right? So $7. Thank you so much, Flora. Now we have 2 more questions to go before we start our new chapter. So we have, oh, this one is so much fun. This question 9. I like this question very much. Who wants to do this one? Okay, 师哥, go ahead.
Leo used some buttons to form a square. If there are 4 buttons on each side of the square, how many buttons did he use to form the square?
Okay, 师哥, hold on. I'm going to draw a picture here again. So we have a square, and we also know that he has 4 buttons of each side of the square. So 4 buttons here. Okay, so that's basically what he had. And the question is asking how many buttons did he use to form the square? So what did you do, 师哥? Did you just count, or did you have a simpler way to do it?
I did 4 times 4 and I got 16. It was very simple.
4 times 4, you get 16. Anybody has a different answer than that?
I have a different answer.
Kevin, what do you have? What number do you have?
My answer is 12.
Okay, so 12 and 16. Do we have a different answer than these two? From these two, a different answer?
My answer was 12.
Okay, so we have 2 votes on 12.
And I think I know the mistake he made. I made this mistake
Very
and then
good.
I got corrected.
Yeah,
Me
that's
too.
very good. Okay, so
I
okay,
have
guys,
16
let's
too.
first count. Okay, we're just gonna count from, we always do clockwise or anti-clockwise. But anyways, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Turn out we have 12, but this is very confusing, right? So what we do is that we can say there are 4 buttons. There are 4 buttons on the corners, okay? So there are
so like you can't get them
Yeah,
to be used
and
2
they are
times.
shared, okay? Is that right? They are shared. So for example, this 4, this 7, 10, and 1. These are shared by 2 sides, right? So when you do that, you can do 4 by 4, but you have to subtract 4 because you counted that one twice when you do 4 by 4. Okay, and another way really just to do, okay, so there are unshared ones. I'm telling you guys this method is because sometimes it will give you like 8. What about 8 per side, or even bigger, 100 buttons per side? Then what do? So you have to do the unshared, which means these guys, right? These guys are not shared. So the unshared buttons there are 2 by each side. And we have 4 sides, so there are 8 unshared buttons. And then the shared buttons are the 4 on the corners. 8 plus 4 equals 12. Sugar, did you see where you get it wrong? Yeah? Yeah, so you counted those 4 twice. That's a very, very, very easy mistake to make. But now you guys know it, right? So it's 12.
My dad corrected me after I made the mistake.
Oh, good for him. Good for him. Yeah. Okay, now we're moving on to the last problem. Okay, last problem. Who wants to do it? Oh, okay. Andrew, go ahead.
A light rail train takes 10 minutes to reach the next station. It stays at the station for 1 minute before heading to the next station. If Kevin boards the train at the first station on time, how long will it take him to reach the fourth station?
Okay, Andrew, I think you made a mistake. It's 5 minutes. Did you say 10 minutes? I heard.
Oh,
Yeah.
Oh, shoot.
Okay, but hold on for a sec. I need to draw 4 boxes just to represent the 4 stations that he's going to the train is going to pass. Okay, so we have the first station, we have the second, third, and fourth. Okay, now for each station, there is a 1 minute. So 1 minute stop here. And then for each station, to reach the next station, it takes 5 minutes. So this is a 5, that is 5, this is a 5. So, Andrew, what do? That's the picture.
So, for me, if the train moves 5 minutes to get to the next station, right?
Right.
So then it waits 1 minute. So how long to get to the fourth station? So the last 1 minute is cut out. So then if you add 5 plus 1 plus 5 plus 1 plus 5,
Okay, you can do that.
23.
Plus 5. This is a 23. I don't think this is a 23. Anybody has a different answer? Andrew said 23. Is this 23?
My different answer is 18.
It's 18. Do we have any other
Mine
answer?
is 18.
Mine is 17.
Mine is 18.
Oh, 17. Okay, you know what? It's 17, guys. So let's see why we get to 17. First,
I knew it was a bit
hold on. First, the train leaves the first station and goes to the next one. Stays at the next station for 1 minute. Takes 5 more minutes to reach the third station. Stays at the third station for 1 minute and takes another 5 minutes to reach the fourth station. Does the train spend 1 more minute here? It will, but we don't care because the question was asking you how long will it take him to reach the fourth station. It did not say how long will it take him to start from the fourth station to go to the fifth, right? So we don't count that 1 minute anymore. So that's where these people probably made a mistake. Okay? And then I don't know where that 23 comes from. This is a big question. So what we do is you can either do this, you add these up, you should get 17, or you can do 5 times 3. That's basically the 3 intervals among the 4 stations. and plus the 2-minute stay on the second and the third station. So you should have 15 plus 2 equals 17. Right? Any questions? Any questions? No? Okay, we're moving on to chapter 7. Okay, before we go to your book, I want to make sure everybody is good with their money expression. So let's look at some easy problem. Okay, so this is not word problems. These are just, you know, very, how do I say this? Very straightforward, right? We're looking at expressions, money expression. So first question here.
Yeah.
First question here, I'm going to give you guys, okay, 2 minutes, 2 minutes on the first 4 questions. Okay, and then I'm going to ask for volunteers and to work with me on these 4. So task number 1, express money in figures and in words. Okay, first 4 questions. Take a couple of minutes to work through them. Okay. So it's pretty straightforward, right, guys? It's basically asking you, so the first 2 problems basically tells you money in words, and then it asks you to translate that words into figures. So now let's work on them together. $3.51. Okay. So what we can do is that we can write 800, 3.51. So this is a dollar, this is a dollar, this is a cents. Okay, so put them together. That's 800, 803. Put a little decimal point here. 51, that's your cents. So why do we do that? It's because 51 cents is basically $0.5. Okay, 100 cents is $1. Okay, so that's the basic conversion here. 100 cents makes $1. So this is how you express your money in figures. Next question. Do we have a volunteer? I just did one for you guys. Do we have a volunteer who wants to work on this one? Flora, go ahead. So what's the number here? We have 1,000, then we have 200, then we have 63, and then 7. Okay, then what do we do? What numbers do we have here?
1,000.
1, 2, 6.
3.
Point, yeah?
Point. 0.
0. Wow, beautiful. Flora, so good. You put a 0. Okay, so that's the trick here. So if you don't put 0, what does that mean? If we do 7, that's 70 cents. That's not 7 cents, okay, guys? That's 70 because there is a 0. Right? So if you put 7 there, but actually you need to reverse. You need to put 0 because it's only 7 cents. That's a trick. Wow, you did so well, Flora. Okay. Now the next one, I want someone to translate these numbers, $99.08. Translate that into words, and I'm going to write it down. Okay, Ethan, go ahead.
$99.
99
$99.08.
and 8 cents. Okay, very good. Now the next one is a little bit hard. Kevin, the next one.
3,400.
Okay, hold on. 3,004. You said 400.
Yeah.
And then $5 and
36
36 cents. Very good. Okay. Task number two. Calculate the total value of the coins given. Okay, take 1 minute here, guys. 1 minute. And then I'm going to ask you guys what your answers are. By the way, for those of you who are not familiar with these, a quarter is 25 cents, a dime is 10 cents, a nickel is 5 cents, and a penny is just 1 cent. Okay? All right, who wants to work with me on the first problem? Who wants to work with me on the first problem? Let's see. Ooh. You guys look okay. You guys are smiling. That's good. Abigail, Yunyi, are you girls ready? Okay, Ethan. Ethan, go ahead. Ethan, why don't you start with the first one?
The answer is $4.10.
Very good. So we can do 4.10, or we can just say $4.10. $4. Let me just spell everything out. And 10 cents. So let me move down here because I want to show you guys how we calculated for the first problem. So for the first problem, we have 10 quarters, right? So we multiply 10, we multiply 25 cents by 10. And then for that 10 quarters, we should have 250 cents in total. Now for the dimes, we have another 10 dimes. And for that, we do the same. That should give us 100 cents. Now we have 10 nickels. That gives us 50 cents in total. Okay, guys, if you are not invited to speak, can you put yourself on mute? Thank you. Always remember to mute yourself. Otherwise, I can hear all the background noise. Okay, so then we add all of these up, right? So we add up 250 and 150 and 10. So if you do that, so these two, we add these two together because that gives us 300. Then we add 300 and 100. That gives us 400. So 410 cents. And that basically is $4.10. Very good. Thank you so much, Ethan. Now, who wants the second problem? This one is a little bit more tricky because now we have all these, numbers that are at odds. So who wants to do the second? Ethan Roberts, go ahead.
$3.18.
You know what? I don't even, I need to work on this because I don't even have an answer myself. So let's work on this together. 13 pennies. What do we do, Ethan Roberts? 13 times 1? Yeah, that gives us 13 cents, right? And 2 nickels. What do we do here, Ethan Roberts? 2 nickels.
2 times 5.
Very good. Thank you. 2 times 5. That gives us 10. 17 times. So I'm going to do, 17 times 10. That's 170 cents. Now the last part, 5 times 25 cents. What do we have here, Ethan Roberts? What should we have here? What do we get here?
5 times 25 is $1.
Is let's see, 25 times 5, that's
Oh, I mean 25. $1.
125. Yeah, 125 cents. Now add up all these. 125 add up with 170, that's 295. Now we have a 10, so that's 305. And then we have a 13. Now that's, did you say $3.18?
$3.18.
Wow, okay. You did so well. Thank you so much, Ethan Roberts. So $3.18. We can do, or $3.18. Okay. So you can express them in either of these forms. Now, any questions before we move on to the word problems for in chapter 7? Any questions? No questions? So now let me see what I wrote down in here. Oh, Ethan, do you have a question? I see you raise your hand.
No, I'm just stretching.
Oh, you're stretching. Yeah, everybody's tired. Are you guys going back to school or are you doing online?
Online. Some of my
Online.
classmates go back to
Oh, you're
school.
still okay.
Some people go in my class. Some
Online.
people go back to school. Some people stay online.
Okay.
Some people stay online, some people go back to class.
We can change.
Same for me.
Where are we going?
Hold on,
Yeah.
guys. Yeah, I hear you. So now, you know what? Can you turn to page 81? All of you. Page 81. And we are going to start with the practice questions as usual, because, sometimes these questions are actually hard. I don't know if you guys actually do them, but I strongly suggest you practice more. So even for the homework, we only review the challenging problems. I strongly suggest you finish all of the practice questions. Some of them are really, really tricky. So this is page 81 again, and we are starting with 5 and 6, okay, for the challenging word, not challenging, for the practice questions. Okay, does anyone want to work with me on question number 5? Yeah, Andrew, I know you did it. How about Yunyi and Abigail? You girls? No? Not ready? Okay. So hey, Andrew, you can start with 5. Andrew, are you muted? Yeah, good. Thanks.
Antina wants to buy a box of chocolate. She has $1. After borrowing 3 from her father, she still needs $2. How much does a box of chocolate cost?
Okay, what did you do? What did you do, Andrew?
So
Okay, let me draw a picture first. Okay, so she has, Anita, she has $1. So that's what she has. Okay, so each of this box is $1. And then her father gave her 3. So that's like, I'm gonna just put 3 equal sized box here. So that's the $3 she got from her father.
6.
Yeah, and then she still needs 2. Okay. She still need 2 of these boxes. This is the ones that she does not have. So this is what she has. This is what she needs. Okay, so now the question is, how much does the box of chocolates cost? Okay,
$6.
so $6. Okay, so 1 plus 3 plus 2, right? Very good. Thank you. Yeah, when you do this, when you draw it out like what I did, then it becomes quite clear. Now we're moving on to question number 6 for the practice
Already
question.
quite clear for me.
Pretty clear. Yep. So the next one. Do we have, let's see. Shige, you want to work with me on this one?
All right.
Yeah, go ahead. Can you read the problem first?
Mrs. Deanne wants to buy 2 sacks of rice. One sack of rice costs $18. She has $28 in her purse. How much more money does she need?
Okay, so wants to buy 2 sacks of rice. Each of them costs $18. Okay, so this is my rice. Okay, 1, 2. Each of them is $18. And she only has 28 in her purse. How much more? Okay, so she has about here. What she has is like 28. So we're asking if she wants to buy the 2 sacks of rice, how much more money does she need? So we're asking about this part. Okay. So, Shige, what should we do? So we need to figure out first, how much do the 2 sacks of rice cost, right? How much money do 2 of them cost, like the total money she would need? Okay, so that's 18 times 2. That's, what is 18 times 2, guys?
18 times 2 equals 36.
Very good. Thank you. 36. And now she has $28. So Shige, how much more money does she need? What should we do? How much more? She needs 36. She has
36 minus 28.
yeah, so just subtract the money that she already have. So 36 minus 28. What should we have? What should we have for this number here? $8, right? Did you guys have $8? Does all like Shige, do you have $8 for your answer?
Yeah,
Okay,
I do.
very good. Yeah, any questions, guys, before we move on? Any questions? No questions? Now, can you guys turn to page 82? 82. We are going to work on problem. Oh, hold on. Not 80, not 82, 83. We're going to work on problem 9. Okay, let me grab it here.
Is not a challenging problem.
It's not a challenging problem, but this one can be quite tricky too. Okay, so I'm going to give you guys 1 more minute. I know a lot of you did not do these problems beforehand. I'm going to give you 1 minute to read through this problem. And then I'm going to ask a volunteer, okay? So this question is quite similar to the 4 operation problems we just did in the homework, in last homework. It's quite similar. We're going to build a model like what we used to do. So anyone who wants to work with me on this one? Ethan, go ahead.
Sue and Becky had $38 altogether. After Sue donated $8 and Becky donated $10 to charity, both of them had the same amount of money left. How much did Becky have in the beginning?
Okay, so let me draw a picture here. So I'm gonna do Sue on the top, and then Becky here. So Sue, we're gonna just use this bar to represent the Sue, okay? And we're gonna do Becky here. So we know that Sue donated $8. So she gave away this part, $8. And then Becky donated $10. And after that, they have the same amount of money left. So the shaded part is equal. This is equal size. And they have all together in the beginning is what they had was $38 altogether in the beginning, okay? So after giving away this amount of money, $8 for Sue and $10 for Becky, what they have is the two shaded bars of equal size bars. Okay, so they have the same amount of money left. The question was asking, how much did Becky have in the beginning? How much did Becky have in the beginning? So Ethan, what should we do here? Guys, this question is quite tricky, right?
I needed my dad to help
First,
me with it.
I subtracted 8 from 38
Very
and
good.
then 10. So I got
Okay.
20.
So
So both of them,
$30 and then, oh, sorry, 30 subtract by 10, you get 20. So what does this 20 represent?
how much they had left together.
Very
So
good,
both
Ethan.
of them
Thank
had
you
10.
so much. Yeah, that is exactly what this $20 is. So $20 is what they have left together. And we know that they have the same amount of money left, the same, right? So what do we do here, Ethan?
So Becky got $10 and Sue got $10.
Very good.
So
So
Becky
$20
donated,
divided by 2, they each have $10 left. Each has $10 left. Okay, so that's what $10 represent. Now the question was asking, how much did Becky have in the beginning? This is before the donation. Then what do we do?
since she donated $10, 10 plus 10 equals 20. So at the beginning, she had $20.
Very good, $20. So this is what Becky had before she donated the donation. Okay, yeah, thank you so much, Ethan. That was so good. Now we have time to do I am going to try to work on 2 problems. Okay, so one problem is let's see, page 84, the first example for the challenging problems. This one is quite interesting. There is a little trick there. As long as you are not confused by that, and this problem should be just as what we did for the 4 operations. Okay, so do we have anyone? Do we have a volunteer who wants to work on this? Kevin? Kevin, why don't you read this problem first?
Joshua and his 2 brothers each receive 50 cents a day for lunch. How much will they receive in 5 days?
Okay, so Kevin, let me draw a picture here. So we want to make sure that we understand this question completely, okay? So Joshua is here. Oh, why did I draw? I put a dress on him, sorry. Okay, that's not Joshua. I'm gonna do something like that. Okay, and his 2 brothers, Okay, so Joshua and brother number 1, brother number 2. How many people are there, guys? How many people are there?
3.
3, right? We have 3. So that's the trick. A lot of people would just take this number and go. They would just take 2 and then do the whole thing. And then they find out, oh, what? I forgot about Joshua. So why I do this, why I draw them out is just because I want to understand the problem slowly and completely, okay? So 3 people are there, each receive 50 cents a day for lunch. So every day, I'll put every day 50 cents for all of them each, okay? Not for all of them, for each of them 50 cents a day. Now we're asking, how much will they receive in 5 days? So day 1, right? This is day 1. Day 2, they would have the same amount of money. And 3, 4, 5. So now the question has become quite clear. What do we do here? Kevin, what do we do here?
50 cents plus 50 cents plus 50 cents. 3 times 50 cents equals $1.50. They
Okay.
have $1.50 each day.
So $1.50 each day for all 3 brothers. For all 3. Then what? Now for 5 days.
Well, for 5 days.
You know what? For the Kevin, for the operation here, we can actually first put this $1.50 to 150 cents. Then we can do what? Then we can do
then
150 cents times 5, right?
Equals
We can do that.
7 equals $7.50.
Very good. So equals
$7.50,
750 cents, which is basically $7.50.
aka the
Very
answer.
good. Thank you so much, Kevin. And oh, we don't have much time left. I want to talk about, let's put a real contest problem. Instead of doing another challenging problem, let's do this one. This is a kind of easy problem. Why don't you guys just take a minute to finish this problem? Then I'm gonna let you guys go, and then you know the drill. Your homework is definitely all of the challenging problems in chapter 7. And if you have time, please go over the practice questions too, because some of them are really, really hard. That's how I felt. I did all of them. Okay, the real contest problem, find the sum of these numbers.
I found the sum.
What's your number?
330.
Okay, let me write it down. 330. Do we have a different number? Do we have a different number? So this is basically your chapter 4 in your book. I think it's chapter 4, right? Let me go back to the table of contents. Yeah, so this is basically your chapter 4. So in your chapter 4, you have, this is called mental calculation. So it talks about a lot of these tricks. And this problem, this example here is basically one of the tricks that I'm gonna show you. Okay, so instead of, a lot of you will just go with the order. You're gonna add 2 plus 4 plus 6 plus 8. Instead of doing that, we're gonna look for pairs. Any pairs that gives us 10, 100, 1,000. All of those are very, very, very welcome, because we know that these numbers are so easy to work with, right? So we're looking, 4 and 6, that gives us a 10. What else? 2.
There's 100 in the end.
Yes, there's 100 in the end, and let's not worry about it. So 2 and 8, that gives us another 10. And then 20 and 80, that gives us, what number does that give us, guys? 20 and 80. 100.
100.
What about 40 and 60?
100.
Yeah. So now look, I can write this whole thing to 10 plus 10. Don't forget we have a 10 here. Plus 10 plus 100 plus 100 plus, don't forget about this 100 in the end. So that's basically 30. Yeah. You know why we do this? This way it's fast. It's fast, and you also, it's less likely you make a mistake, right? Less likely to make a mistake. Okay, I'm gonna let you guys go. So I'll see you next Tuesday. Bye-bye, guys.
Bye-bye.
Bye. See you next
Bye.
Tuesday. Bye.
Bye, Uni.
Bye. See
Bye,
you next
Uni.
time. Bye.